Coolio. So today we are going to talk about technical art. It's a big part of games, especially whenever you get to more AAA ones. Usually, if you're on a small team, you have your programmers, you have your artists, and you have people in very set roles. But technical art, getting into that, is it basically acts as the communication bridge between artists and programmers. That's just one of the things that they do, but it's basically they can do programming for artists and they can do art for programmers. It is a lot of using both sides, your left and your right brain, at the same time. Some other things that they help do is they help implement art and design work into the game. So that can be asset implementation, that can be working on materials, that can be making sure those animation blueprints working all right, everything like that. Something else that they do is create and design tools and pipeline workflows for the team. So making sure that not only the artists have the tools that they need to make everything run effectively, but also that all the workflows are done so that, if people want a new feature, they know exactly how to approach that so nothing else gets broken in the process. So there's a bunch of core skills. Tech artists are known as the jack of all trades, basically, in the games industry. And some skills that they need to understand is, first of all, artist advocacy. Usually that means that they've been in an artist's shoes themselves. And it means that they know what an artist needs and that they can sympathize with that, not only for UI if they're building a tool, but also understanding the workflows that might need to be put into process so that artists can get their work done as easy as possible. Another thing is optimization and performance. So another thing, tech artists sometimes overlap a lot with software engineers, such as doing rendering work, physics programming, optimization is a big one, and just making sure not only that the tools are optimized, but that the workflow is as well. Another thing is communication skills. You work a lot with a team. You need to know what they need on both sides and communicate a lot with many different people. And other stuff is experience in art disciplines. Knowing the workflows that usual artists use is incredibly helpful because that, once again, allows you to sympathize and advocate for what the artist may need. Yes, just kind of like everything else in video games, you do need to know some physics and math. That's fun stuff. That's mainly for asset implementation and making sure that everything can get in and works all well together. And especially as you dive into shaders and world position offset graphs, stuff like that, you need a lot of physics and math to make sure that everything looks right. And that problem solving every day is a new challenge. You're not making new you're not making new animations. You're not creating UI buttons. No, you're getting a new problem to tackle every day and being able to provide support to other people on the team. And you do need to know some programming. That helps. So there are many disciplines. I'll cover a couple of them, but the first one is character rigging. So making sure that your characters, first of all, have nice UV maps, but usually that's the artist's job. And being able to set up all these characters or objects with rigs so that they can be animated by the animators. And this may provide different modifiers and making sure that everything is nicely weight painted and adjusted so that if I move this bone up here, it actually moves the shoulder with it, stuff like that. And it makes the animators' lives a lot easier. And also, if you have a good rig, it makes the rest of your game look really good. And the next is pipeline and tools programming. So this could be if I was in Blender and I wanted to automate a process because I realized I kept doing it over and over and over again. That's something that would be done by a tools programmer because they would just take that and create a script that would automate that whole process and make it so that the artist can just quickly run it and everything's good. Next thing is shaders and materials. So up there is the Unreal shader graph, and down here is just some basic stuff in terms of materials, which we will be going over later. So if you have Blender on your computer, you might want to pull that up. Secret hint for later, because we'll be doing a shader of our own today. And yeah, so this is a big part of it. It's the perfect combination of math and art, because you have to basically, shaders are just a more efficient real-time way of animating a post-processing or effect on an object in your game. This could be like the oceans in water stuff in Unreal use shaders to have the look that they have. And you can even edit those to maybe make them like toon-based or have the foam of the waves have a different effect, stuff like that. Yeah, the next one's VFX. This one's pretty popular. Making sure that if you shoot a bullet, it actually looks like a bullet. Making sure that you got smoke, rain, particles. This is usually done in Niagara within Unreal Engine as well as Houdini. So if you're interested in that, I would look into those programs. And then there's also asset tracking and management, just making sure that all the folders are well kept and that naming conventions are standard so that people don't get lost in there. Other things that I didn't mention are UI and UX design, making sure those buttons and everything like that all work together. That's usually the part of a tech artist. And there's so many more. It goes into kind of every part that mends art and programming together. But yeah, so we're going to go into an intro into materials. So if you would like, you can follow along in Blender, which I'm going to pull up. I've gotten a bit of my scene already set up, but it's not too much. It's just changing the background color because I like it brighter. Yes?
Do you want me to like run around and help people if they have questions while you're going through this?
Yeah, sure. Whoa, where'd everything go? There it is. Okay, cool. Let me grab my blender. So I already put a little monkey in there. Suzanne! Yeah, so Suzanne's in there, having a good time. Also, I just changed the color to be blue. So if you want to add the monkey, you just have to Shift A, mesh, and then hit monkey. And it'll add that for you. Monkey. Suzanne is a very established thing in the Blender community, and it shows good curvature so that if you're ever trying to do something with shaders and materials, it gives you a good overall reference to what it might look like on another object. Yes? Yeah, so you just hit Shift A to add an object, mesh, and then at the very bottom it will say monkey. Yeah. And the other thing you're going to want to do is you're going to want to open up the shader viewport on your bottom part. So that will allow you to view the shaders and materials that you're going to be working with and utilize those graphs. So you'll see whenever you first open Blender that you have the animation, I think, blue? Yeah. Yeah, so you can just click this little node right here, and it'll give you all the options, and it'll have the shader editor on one of those. Oh, it's all good. I understand. Yeah. So I'll quickly go over just some basics of materials. I am on my mouse, so bear with me. My trackpad, I'm sorry. But yeah, so the first thing we're going to want to do is we're going to want to add a material. So you can do that either by clicking the object and clicking this material button here, and then here you can hit new. And you'll see a lot of stuff pop up. I'm just going to rename it to monkey. Usually the naming, monkey. Usually the naming standards are M and then whatever object you are making the material for. So you'll see a lot of stuff. In Blend, every single thing, like software, has a different lighting and shading model. So whatever you have in Blender, if you try and do it and replicate it in Unreal, it's going to be different. You can still get the same effects, but the names will be different, and it might have different nodes that you can enter in. But yeah, so this is the basic shader that you can mess around with in Blender. So this is the principled BSDF shader. And there's a couple other ones that you can look at. So it goes into just having some of the nodes in it to, hey, if I wanted something glass, if I wanted translucency, transparency, there's a lot of stuff you can do with it. Oh, thank you, Carson. But yeah, so going into some of the things on here. So there's a lot of different parts. I'm gonna go ahead and extend this upward so I can get a better view, so I can show it a bit better. Come on, where is it? How can I? Ah, there we are. So we're gonna look into this. Alrighty, so you're gonna see a lot of stuff on here, and I promise it's not as scary as it appears. But all of these nodes mean something different for the character, and the first one you'll probably notice is base color. So this is called something different usually in different softwares. It can be base color often, or it can be, I've seen it sometimes as albedo and also as diffuse. So if you ever see anything like that, it's probably just the base coloring. And this, as you can probably guess, I can move it around and the base color just changes. So then you can get into more fun stuff. So the base color is obviously changes the color. Roughness is the next part of that. Oh, and also if you want to see your material, you go up here on these shading viewports, and you're gonna want to hit viewport shading up here. This little bar right here. So if you weren't seeing it before, this will help you see it, because you'll be on regular like edit shading, and then you'll go to shader shading. But yeah, so the next one, which is another basic one, is the roughness. So if it's lower, it's going to be very glossy and shiny. As you can see, it has that sort of light reflection up top. Ooh, pretty. Yeah. And as it goes to 1, it's going to be completely flat shaded. There's no shininess at all to it. And so that's what roughness does. It basically edits the specular reflection and transmission of the material. The next thing is metallic. So it kind of does a similar thing to roughness, but instead it takes it in more of a metallic approach, obviously. So in this, you just put it from 0 to 1. It's kind of the opposite of roughness. So if I just had roughness back at 0.5, this will have more of a metallic shine to it. And you can mess around with all of these. It's really just how light is going to interact with your object and how reflections will be a part of that. So the next thing I'll talk about is the index of refraction. So this right here, the IOR. So that is for the level of specular reflection. You usually don't see much of a difference, so you can leave it at 0, but if you ever wanted to make something more shiny, you would turn that up as well. The next thing is the alpha. So the alpha controls transparency. I don't think it's showing up very well in here. Might be because I got metallic all the way up. But yeah, alpha just shows transparency in the object. As to why it's not doing it now, I have no idea, but I'll figure that out later. But that would usually, if you have a mask on it, it could show more parts with kind of like a kind of gradient texture from a lighter to a darker color. Yeah, and there's other things. I will say emission is also pretty cool because you can make it glow using this. I don't know how well it'll show up with the lighting I have set up. A lot of this is also dependent on the lights. Currently, I just have a sunlight.
How did you put a sunlight? How did you put like a light in?
Yeah.
It's like the basic light,
Mhm.
but the face is just not.
Yeah. So you can select your light, which it should be a point light whenever you first get into Blender. And you can select sun. And here you can turn down the strength, you can change the angle, you can move it around, everything like that. Yeah, you can also change it to a spotlight and an area light, but I would keep it at sun for now, just because it. So the different types of lights, which is also tech art, so I will delve into it a bit. But for lighting, there are 4 basic types of lights. There's point lights, sunlight, spotlights, and area lights. So a point light basically is just from this one point, it's going to send out light from it. So if you think of a light bulb, that would be a point light. The sunlight, it's going to basically be a point light, except it's in every, think of it as like a plane, and it's shooting down the light from that plane across all of it. Kind of like the sun. Easy comparison there. The spotlight is, as it's named, if you've ever been to the theater, it kind of shows it in a cone. And it will have that area. And you can adjust things like fall off, all that stuff, and make it a bit smoother. And then the last one is an area light, and that's, to my knowledge, I don't use area lights very much. But that's kind of like the sunlight, but within a certain area that you can set. Yeah, so that those are your types of lights, and you can edit a lot with it. But for right now, I'm going to keep it on the sun. So yeah, the other thing I really want to touch on in terms of basic material attributes is the normal map. So normal maps are, if you've ever seen the very like purple, pinkish, very bright texture in a 3D model, that is what's called a normal map. I will find a good image of that.
You just Google it.
Yeah. So, yeah, so this is a normal map, right? So this is, if you had this brick texture, it basically tells your rendering camera that there's basically a fake depth. So this could be just a flat plane, but it would render it as if it had all these grooves and it had this kind of inset in terms of the brick. So you would perceive depth, but in reality it'd just be a flat plane, which is how a lot of games save on computing power, because they're not rendering polygons, they're rendering normal maps, which is a lot less expensive. So yeah, that is what you'll plug in. Those are a bit harder to make, just off of it. Those, if you're interested in the high to low workflow, yes.
Go ahead.
If you're interested in going from a high poly to a low poly mesh, that is where you can bake a normal map. And if I were to actually sculpt these bricks and make it so that they had this depth, or if I used Substance Designer to actually like piece all of them together, I could then bake a normal map and put it onto a low poly mesh. And it would have this normal map that it could then display as texture. But yeah.
How do the colors work with it?
Yeah, so each of these colors is a separate ID. So it basically takes each of these and it sees this pink obviously as a separate ID from this blue, and all their RGBs correspond with a different value, and those values are seen as different normals. And if you're familiar with normals, I can show you on Blender. If I can get Blender back up, where'd it go? There she is. So normals, I'll drag this bad boy back down. But normals are, as these faces, as this model has faces, it also has normals attached to these faces. And those are arrows basically pointing outwards from this flat mesh. So this would have an arrow pointing out kind of this way out in 3D space. It takes that flat plane and just has an arrow shooting perpendicular to it. And that's how it does a lot of the lighting. And it's also why normal maps are able to do what they do, because it changes the normals on here from having a normal on each of these like planes to having an individual like ID on the texture map. So it's able to provide a lot more information and depth to the material. Is that a good answer?
Yeah.
Okay, cool.
Just to make sure people knew, like,
yeah.
the connection was.
Yeah. So, yeah. So as you can see, there's a lot of things in here. It gets even more in depth as you go into Unreal, and then it has even more different types of shaders that you can mess with. Other things are Specular's pretty cool. It mainly deals with when you're working with metallic. It kind of works as a kind of a reflection off of that. And these are all things I would suggest you play around with, and it's more fun whenever you actually experiment and see what they do in real time. Other than that, that's kind of the basic stuff that we have here. One of the other ones is subsurface. Subsurface scattering is stuff you would do in a render rather than usual video games. Video games, it takes a bit more computing power to do. But it's basically as it reflects, if you were to see a leaf from below, the sunlight would go through it and you would see a bit of a lighter color, like kind of reflect off of it than on the front side. And that's how you can control that, is you could set that color and you could set that amount. It's just how those reflections work within when they bounce off. But yeah, alrighty. So we can now start working on our shader. So we are mainly going to work on doing a sort of toon shader. So we are going to go ahead and start off. The most basic thing that you can do for a toon shader is you're going to want to first separate your shader from your material output. And how you can do that is you can do that through the shader to RGB. So how you add it in this shader graph is similar to how you add objects in Blender. So you just hit Shift A and you can search, which is awesome because then I don't have to filter through a bunch of folders. You just hit Shift A, touch the search, and then I can look up shader to RGB. And I can just place these in the middle. It'll auto-connect it. It's pretty awesome. Actually, I don't know if that's a plugin I have installed.
It's not, it works.
Okay, awesome. Because I do have some node wrangling extensions installed, and I wasn't sure if that would make things difficult or not. Bless you. So yeah, and after that, what you're going to want to do is it basically is taking this shader that has computed everything separately, turning it into those RGB values. So kind of like if you were to bake it. So do people know what baking means in this context? No? Okay. Naila does. Hell yeah. Yeah. So baking is basically you did art, you were cooking, and you're done with it. So, but you do have all of it in here, but you're done with it, but you can't exactly bake out, like you can't take nodes and put them on something else. It has to be like an image you attach to your material rather than a bunch of nodes that aren't really going to be able to be attached to a FBX. So in order to do that, baking needs to be done. So that basically it renders the UV map texture, the texture that's on the UV map, and basically takes a screenshot of what it currently looks like and exports all those. So that's what baking is. It's basically just taking nodes and turning them into those images, which you can then apply in other places. That's how things are usually transferred from one program to another, even though they all have different stuff in them. But yeah, so the next thing that we're going to want to do for our toon shader, I'm also going to get out of edit mode because I don't want to be in edit mode anymore. I don't want to look at that. I want to see Suzanne. So we're basically baking this shader that we have here, and we're baking all this information and these attributes into RGB. And from there, what we're going to want to do is we are going to want to add another node, which is going to be the color ramp node. And you can place that. It doesn't look like it really wants to go in automatically, but if you can, I just probably didn't spread them out enough. Oh. Okay, cool. I thought my computer crashed for a second. It is a Mac. it sometimes hates me. Okay, cool. So it did let me do that. So this is the color ramp node. There is, I want to say, I could be wrong, but 80 nodes in Blender. It's a lot. Unreal has even more. But if you take the time and learn all of them, the stuff that you can do with it is incredible. Because even with just adding these 2 nodes, I can then move this here and move this here. And now it, ooh, whoa.
Oh wait, we got bands. Yeah, sure. That's easy. He became my band.
Yeah. And I can basically take this here and all of the darker parts of the model and the shading have been turned to this color. All of the lighter colors have been turned into this one. So this is how you kind of do a toon shader, is because, yes?
Alternatively, you can change the blended from linear to constant.
Yeah. It's just taking it, yeah. So there are a lot of mixing nodes to it. So other ones are like ease, so it'll kind of ease. There's a lot of just mixing nodes to it. Constant. Whee! Yeah. And I could make it so that I want all these lighter areas in here. And you can also change these colors. So if I wanted to move this one to be pink, I could do that because I like pink. But yeah, so that is the basics of kind of cell shading, which is fun. And you could also subdivide this and add that as well so that it could basically create a smoother effect to it. And let's say I wanted to, whoa, I didn't mean to delete that. It's okay. It's okay. Let's say I wanted to make this 3 colors. I could just, there we go. Make that one. I really like pink, so we're gonna stick with the pink. Usually I don't work on trackpads. You guys are gonna have to give me some slack here. And making sure that those highlights are really in those parts. And yeah, and so it would have more of a color ramped effect to it. Whoa. There we go, buddy. Yeah. So this would be the basics of our toon shader. Cool. So we got, usually in a toon shader, you're gonna want 3 levels. You're gonna want your basically highlights, your shadows, and your midtones. So that's usually what you want to do in toon shaders.
So they each like control the region that's like right above them?
Exactly. Yeah. So yeah, you got it. So now there's some other stuff we can do. Yippee! Always got to make sure to look at my notes. Yeah. Cool. So there's some other stuff that we're going to work on and that we can do. And as you can see, there's so much stuff that we have here, right? So we have inputs that we can put in, so that can be like values and attributes that we can assign here and then input into a lot of these attribute inputs. Other stuff, we have all of our shaders. We can actually take this shader and mix it with another one, which is cool. And if you want to do that, that is something you can do. And one you'd probably use a lot is the image texture. So the image texture is where you can input things like your colors, and if you like painted on your model, this is where you'd upload that. So I'm gonna go ahead and get rid of these for now and showcase that. So I'm gonna try and find an image. Yeah, that's a good one. Perfect. Yeah, so this basically would take the UV map and just apply that image onto it. And usually usually you would have the UV map and paint onto it in a different program, and so it would be mapped to the image you have and would upload would be matched to those UVs, so it would actually look right. This is just a plain PNG of a character. So it would, right now it's just being applied right here. But you can also plug things in for roughness. Basically any of these attributes, you can plug things into it. And from these image inputs. Yeah. Coolio. And there's also a bunch of other ones. So another one we can take a look at is, there's gradients, which is fun. So I could take this, put this into here. Yippee! It already kind of did it. Yeah, gradients. Yippee! But there's a lot of stuff you can do. So, I'm also going to show a couple more other than that. Mix RGB. Trying to think of good ones to do. There's not... Unreal has so many. I haven't been in here in a while. Musgrave one's pretty cool. Take a look at that. Yeah, so there's a lot of these like procedural ones where you can have like noise, you can have Voranoise, one of them that's called. And they basically are these flat maps of procedural dots that can get moved. Some of them you can move along with time, which is pretty cool. And you can scale it up, you can scale it down, and some of these will allow you to just make a really cool texture effect on things. And especially if you're using things like panners or anything like that. Yeah. Does anyone have any questions about what we've talked about? No?
Yes, I do.
Yes!
Under where it says GGX and then it says, I don't know how to pronounce the name, Christensen Burley or something. Mine was originally set to random walk, so I was just wondering what the difference was.
So these kind of change with different Blender versions sometimes, which one they have it set at. They are just different ways these are different ways of calculating the subsurface calculations. So I wouldn't worry too much about it. It's okay. Yeah, they are basically the same. You can keep them on whichever one. But yeah, other stuff. Let's see. If you guys just want to explore with different nodes, it's very fun and see what you can create. I'm going to work on something up here if you just want to, I guess, watch that as well. But yeah. Whee! Just kind of fun stuff. What?
What do you think you're going to cook up, Jayden?
Doing watercolor shaders is fun.
That does sound fun.
It's quite fun. So I'm gonna, usually I do some watercolor.
This guy's got a lot of pure white art. It's like I'm trying to do today.
Yeah.
It's so like the little spot that you do the specular is the entire top.
Yeah.
How do you rectify that? Because like I crank the metallic and it gets a little better. Like it's not like easy. So like you know, I got this one, right? I got the color ones right. So at the top.
I saw that message and it was like, oh, it said like, it's like annual.
So close.
shader. Yippee! But this is what you can do with a bunch of nodes. You can make fun stuff. So I've made ones of like 5 times at least that much. It gets more complicated, but this is fun. Yes.
How does it work?
How does it work? I can dive into that. That's a great question. Let's dive into it. Yeah, we have like 15 more minutes. I guess I can just use that to dive in. Yeah, so I went ahead and the first thing I started with was messing with the world. So the world, I wanted it to have this watercolor paper texture behind it that whenever I rotate around, it'll stay on the screen view. And so whenever my screen's facing, it's always going to look the same. And I want that texture to basically be copied across so I can use it also in my boy on the actual like object material. So what I did was I made this paper texture. I made this paper texture node. It's so hard to get it. I hate doing these. I don't know why I do it if I do it. So I made a node group, which basically took the texture coordinates of my camera and mapped it to the texture so it would always look the same. I put that in a hue saturation value changer with some RGB curves to balance the light and saturation stuff. And I put that into a group. And by utilizing a group, it's kind of like making a class in programming. You can reuse it. And so this was made for reusability in my other stuff. So I don't have to remake it whenever I do it. But yeah, so then I went ahead and went into the object. And this is where it got a little fun. But first I focused on, what I did was I added the paper texture node group we just made to it. And I plugged that into an emission shader. So instead of eventually we'd use the principled BSDF shader, but for actual output I used emission. And that's just because it would be on top of this back and you want to just kind of emit off of that. So other than that, after that, you kind of just want to get your noise textures in there. That's your next step that you're going to want to do. I found something really cool online that's just like for getting a good complex 3D noise texture. You can put 3 of them down. You can mess with the scale, distortion, all that. And you can combine them into an X, Y, and Z, which will make the vector. And that you can add to the geometry. Also, I just multiplied all these by a constant. My mouse, I think, froze again. Let me shake the mouse. Okay, it's frozen. So give it 1 second. My Mac absolutely hates me right now. It's like it's running this. It's like it's running The Sims. It's very upset at me. Yay! Okay, it's back. So other than that, I also added the texture coordinates. I took the generated ones, which is usually if you're using texture coordinates, you're usually going to use the generated ones. It's just the standard ones. And I went ahead and added that with the window, so kind of like how it doesn't change when I rotate it around. It also does the same for that. So this is kind of just like a toon shader with extra steps. I plugged that vector into the noise textures, and then it fed through here. And then the most critical point is putting in the layer weight node. As to what exactly that does, I forgot, but it just works. I like know what it does in my head, but it's like it basically takes this normal and it'll put it back out into all these fun guys. Bless you. So then I plugged it into a bunch of color ramps, which we talked about earlier, which is just going to take all those RGB values and assign them to different RGB values based off of their saturation and their point on the RGB. So I multiplied these together, and if I move these around, it'll just change how things are lit. This one in particular, if I change it, it'll affect how sharp the shadows are. And I multiplied those together, and this is my edge weight color. So this is where I would color the edges. I kept it pretty light just because I wanted it to really blend in with everything else. And then I multiplied that with the paper texture, and then I multiplied that with the original principled BSDF. I plugged in these normals I got from the noise textures and plugged that into the normal of here. Turned it into RGB like the normal toon shader. Put that color into here. Color ramped that bad boy, and I can move it around so it'll become darker or lighter. And plug that in with the mix and plugged it all in. That's it. So yeah. You can get very complex and fun results. It also helps if you know math. There's a lot of math. Yeah, it's a lot of fun, but it is a lot of connections and that you have to know kind of what they do. But yeah, so that is that. If you are interested in learning more about materials, it's good to know what nodes mean. So I would, there's great tutorials on YouTube. Specifically, there's this one where it's like explaining all 80 Blender nodes in like 20 minutes or something. And those are really great resources. If you want to, this is a job, is just making these. If you ever want to do that, I would recommend really diving into one shader graph, because all of these are different. Unreal's has a lot more stuff, a lot more capabilities, especially within games. This is more in terms of rendering. I could actually bake this texture out, though, and have it in a game, and be like, whoa, look at that watercolor. But if I was using Unreal, I would probably want to use post-processing instead, and basically make its own watercolor post-processing shader. So there's a lot of stuff you can do. It's very applicable, especially within games, because that's what they were originally created for. And so yeah, I would just take a look at those. Unreal has a lot. My favorite place to start and what to recommend is having fun with doing a lot of stylized shaders and materials. Especially one of my favorites, just because I think it's fun, is doing ones with water involved. Because you do get to learn a lot about how making other meshes interact with your shader. Like if you have a block in the middle of a lake, it'll ripple out and you'll see those ripples. Stuff like that. It's something that you really learn a lot about the process. So if you're interested, let me know. I can send you a very specific YouTube link. This guy is awesome. Highly recommend, especially for stylized things. As you get more into realistic stuff and AAA type game shaders, it does get a lot more complex. Specifically, every single material is done with a not hard-coded, but like a coded shader. So like the skin is usually a shader, hair is usually a shader. They're very fun to dive into, but oh my goodness, these things are crazy. Absolutely, like I want to say 100 times at least what this is. And so I would highly recommend to dive into those if that's what interests you. But there are also a lot of stuff about tech art, so feel free to dive in and become a jack of all trades. But yeah, that is the end of the workshop. Yippee!